All right, so this is my first test lesson. It's going to be really short. I'm going to cover something that sixth period has already covered. Uh, that is a formula for the tangent of x plus y and also x minus y, the sum and difference formulas for tangent. Um, no one's gotten to this except for sixth period. We were able to get to it since we had a few extra uh, days together, but um, let's come up with a formula for tangent. Now, take a second to think about how you can rewrite tangent in terms of formulas that you already know. Go ahead and pause and think about that for a second. I'm going to go ahead and rewrite tangent as the difference between sine and cosine. Sorry, the quotient. All right. All right, so if you have these two things, we have formulas for these. Sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. So if I go ahead and write it as that, we will have a formula for tangent in terms of x and y, trig functions of x and y rather than the sum. That'll be useful later. All right, so let's go ahead and write that. Sine, cosine, cosine, sine. So sine x, cosine y. I do not say SIGN in my little song, so sine, cosine, cosine, sine, all over cosine, cosine, sine, sine, sine. All right, so we got a formula for tangent. It's this. That's disgusting. And actually, the final answer is also going to be not as pretty as the other ones, but what is useful in mathematics is to have a function like tangent, x plus y, in terms of tangent. We want to have a formula for tangent that uses tangents. Why? There's no real good reason, but let's go ahead and just do it. So I got sine x, cosine y, cosine x, sine y, cosine, cosine z. I have a bunch of sines here. And what I need you to do for a second, as I get myself ready to do it, is to think about how you can turn sines into tangents. Alright, so hopefully you paused or you thought about it for a little bit. And turning sines into tangents is very easy. You just divide by cosine. So what I'm going to do, sine x cosine y plus cosine x, sine, cosine, cosine, sine. I'm going to multiply the top and the bottom by, let me finish writing this actually. I'm going to multiply the top and the bottom by 1 over cosine x. I could multiply by secant x, but I like how 1 over cosine x looks a little bit more. So I'm going to turn this sine x into tangents. That's my goal. My goal is to turn this whole big formula into a bunch of tangents. So 1 over cosine x times sine x, that is tangent. And if I move along sine y over here, I want to turn that into tangent as well. So I'm going to multiply that by 1 over cosine y. All right. But I can't just multiply an expression by some arbitrary function. I need to multiply by 1. So I'm going to multiply the top and the bottom by secant x, secant y, or 1 over cosine x, 1 over cosine y, all divided by 1 over x, 1 over cosine x, 1 over cosine y. And this is actually going to get us right there, because if we do a little bit of distribution, we got sine x cosine y times, let me put some parentheses here so it's more obvious. I'm going to take this value, this whole value, and multiply this first term by it. So we got sine x cosine y times 1 over cosine x, 1 over cosine y. Sine x times divided by cosine x, that's tangent x. That was our goal. And the cosine y times 1 over cosine y, that's just 1. So sine x cosine y times 1 over cosine x, 1 over cosine y is tangent x. Beautiful. And the same thing's going to happen over here. Cosine x times 1 over cosine x, that's just 1. And sine y over cosine y, that is the tangent y that we wanted. Cool, cool. Cool, 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 cool. And then over here we have cosine x cosine y times 1 over cosine x times 1 over cosine y. That is just 1. Beautiful. This whole thing's gone. And then over here we have sine x over cosine x. That is tan x. And right here, sine y over cosine y. That is tan y. As I alluded to earlier, this is not much better than this, but it's in tangents, which is nice. If we want to evaluate a tangent, we just need to know our tangents, which is cool. All right, so that, let me try to circle this. Woo, that was difficult on my Wacom tablet. That is our formula for x plus y. So what I want you to do is take a moment to, I'll go back to that for a second if you want, or you can just pause. I'm learning this too. I want you guys to come up with a formula for x minus y. So go ahead and pause and derive that formula yourself and give it a try. I'm going to go ahead and proceed. So tan x minus y, we know a formula for tan x plus y, so let's write this in terms of two angles being summed, and that is just x plus negative y. And then go ahead and pause here if you need that little nudge, but that's going to be really useful, that negative y. We know what tangent negative y is. So let's go ahead and proceed. So we get tan x minus y, tan x plus negative y, and we have a formula for the sum, tangent x plus tangent second angle, negative y here, all over 1 minus tan x tan negative y. Boom. All right, cool. All right, and let's clean this thing up. We got tangent negative y, tangent negative y. That's just equal to negative tan y. Oh, that was difficult. I probably won't do that again. That is the tangent function. It's an odd function. You plug something in, you get something out. If you plug in its opposite, you get its opposite. So jump back down to here. Tangent negative y is negative tan y. So we have tangent x minus tangent y all over 1, and then this negative is going to combine with this negative plus tan x tan y. There it is. All right. And cool, we have two formulas. Here they are. We have tan x plus y and tan x minus y. And tan x plus y is going to be tangent x plus tangent y all over 1 minus tan x tan y. And then the other one's going to look very similar. It's going to be tangent x minus y is tangent x minus, fix that x, tangent x minus tangent y all over 1 plus tan x tan y. And at this point, I can finally share with you Mr. Stein's very bad song to remember tangent. It goes like this. So tangent x plus y, we have, this is a good way to memorize it. Tangent, tangent, 1 sine, tangent, tangent. As you notice, I went faster for the tangent x, tangent y because multiplication is faster in song form than the sum of tangents. Tangent, tangent, 1 sine, tangent, tangent. And then down here, the same thing works. The same things works. Notice when I say sine, that's S-I-G-N. If you listen closely, you can hear the G. Tangent, tangent, 1 second, tangent, tangent. I slowed it down there for you so you could hear the G. Tangent, tangent, 1. We switch the negative to positive, tangent, tangent. All right, notice I don't say sine up here and up here because we don't switch. It stays positive or it stays negative. All right, tangent x plus y and tangent x minus y. All right, so let's use this once. This is one immediate application of tangent x plus tangent y. What I want to look at is the problem tangent 5 pi over 12. So we have tangent 5 pi over 12, and I want to evaluate this without my calculator. I want to use just my brain. And we need to write 5 pi over 12 in terms of angles that we've memorized on the unit circle. So take a second to think of two angles that can sum to 5 pi over 12 or subtract to 5 pi over 12. My hint to you is to go ahead and just write two angles with denominators 12 that the numerators sum or subtract to 5. Hopefully these fractions will simplify to things that we are used to, right? So the one that comes to my mind is 8 pi and minus 3 pi. There are other options. If you look at my answer key, I used 2 pi plus 3 pi. Both will work. Both will give you the same thing. But if I simplify this, I'm going to get 8 pi over 12. That's 2 pi over 3. And 3 pi over 12, that is pi over 4. And we know the tangent of 2 pi over 3, that's negative root 3. And we know the tangent of negative pi over 4, positive pi over 4, that negative is kind of embedded in the formula. We know the tangent of pi over 4, that's 1. Ooh, 1, that's nice. Oh, I like this version better than the one I did on the answer key already. All right, so let's do it. So tangent 2 pi over 3 minus pi over 4. I'm using that song. Tangent, 1 sine, tangent. I'm going to go ahead and add all these angles in 2 pi over 3. We got a minus, we got pi over 4. We got a plus, we got a 2 pi over 3 and a pi over 4. Ooh. Pi over 4. All right, sorry, my handwriting's a little bit sloppy here. Normally it's sloppy. Let's not lie to ourselves. But the Wacom tablet is something I'm getting used to. Okay, so tangent 2 pi over 3, as I said, that's negative root 3. That's just speed trick stuff. Negative pi over 4, that's 1. 1 plus, this is nice because tangent pi over 4 is 1, so we got a negative root 3. Let's go ahead and simplify this thing. We got a negative root 3 plus 1 and what do we got here? 1 minus root 3. And then I'm going to rationalize the denominator. So go ahead and multiply the top and the bottom by the conjugate of the denominator. So we got negative root 3 plus 1 over 1 minus root 3. Let's go ahead and multiply that thing by a 1 plus root 3 over 1 plus root 3. And then let's go ahead and distribute. So 1, 1, that's going to be 1. Oh, this is a difference of squares, so it's 1 minus 3, so that's negative 2. I don't want to forget my negative in the front here. I pulled that out earlier. And then root 3 times 1 is root 3. 1 times root 3 is root 3, so we have 2 root 3's here, and then we have a 1 and a 3, so we have a plus 4. And then this simplifies really nicely. The negatives go away, and we have, what is it going to be? A root 3 plus 2. Boom. That is the answer right there. Tangent of 5 pi over 12 is root 3 plus 2. That's kind of beautiful. Yeah, so we can use these formulas, boom, right here, to evaluate angles that we previously could not. That's kind of the goal here. There are other uses to this formula, I promise you, but right now that's what we're going to focus on. Being able to evaluate the angle of, be able to evaluate the tangent of angles that are not those memorized angles on the unit circle. Hopefully the audio, this is actually the second time I've recorded this, hopefully the audio is better on this one. I think I figured out my problem. But questions, comments, concerns, let me know. This is the first time I'm doing this, so any help from you guys is appreciated. I'm sure you know a lot of this software better than I do. I'm using OBS to screen capture, and I'm using Autodesk Sketchbook to write. Yeah, miss you guys. Let me know what you think of this video, and this is the first one of many, it looks like. Yeah.